Today I'm going to be looking at the Valenta from 4tronix and Hummingworks. It's a joint project. To start with, I'm just going to do a quick unboxing. Right, we have a printed manual. What do we have? We have what looks like a controller board called the Valenta Zero and a microbit plug-in adapter called the Angle Bit. A couple of wheels. Another couple of wheels. It did say it was four-wheel drive. Interestingly, they are of two different types. One, it looks like it's for the normal Metal Gear motors, and one looks like it's for something else, which is interesting. And then we come to the injection molded parts. Let's look at the instruction manual first. Let's do it properly. We've got parts in the kit just to make sure that we've got everything in the box. And it's asking for 2 microbits. Now, I do know a little bit about this, so I've got 2 microbits. I originally only had one, but I bought another one because I thought I'd lost the first one, and then I found it. But fortunately, I've got 2 microbits. Now, I believe, because I've seen videos of this in progress, that you'll need 2 microbits, one for the controller board on the robot itself, and one to do the remote control. So that's good. It's asking me to have 4A single-use batteries. I believe I've got some, but I can just check. So there's a whole load of instructions here. I have no idea how normal YouTubers do this, but I've just got it set up over my shoulder so that you can see what I'm doing. First thing to do is to get your parts out your bags. This is interesting. It's the driver board. It's called the Valenta Zero. It looks to me like it's got a slot for the microbit, an on-off switch, which is always good, ground and 7 to 10 volts, so it will take up to 10 volts, jumper for 5 volt servo power or 3 volt servo power, 2 outputs for the motors, and what looks like some extra servo outputs here. Oh, and all the other pins are broken out on top. The angle bit, where you put your microbit into it and then it breaks it out at 90 degrees. There's the battery pack. So I should be able to take this out of here. Simple battery pack, 9 volt connector or whatever they call it, to a barrel jack. Very normal, standard part. Double jumpers for the micro Metal Gear motors, which are on the bottom. We have got a servo here that controls the steering. I'll just do it gently. Make the front steering. Now, the front steering is, I believe, these ones. So I'm going to slot these on. They click in nicely. It's kind of a slot click. Whee! That'll put your teeth on edge. Assembling the electronics. This is the interesting bit, I suppose. So you take your angle bit, you take your microbit, you plug your microbit in. Okay, then we plug that into the motor driver board. Up that way, and then we connect that to the battery box lid, and then we have our assemblage, the electronics. Here you go. I have my 4A batteries. Check the polarity. Flat end's always the spring. So connector that way. That's very simple. Mount the electronics to the body. We have our electronics assembly, and we're going to put it the right way around, so that's with the microbit towards the back. So as you can see, we've now got everything mounted. The rear wheels have already been made for me. Okay, so there we have it. It's quite a nice looking robot actually, very colourful. We've got our motor driver cables. We've got our barrel jack for the electronics. If I just hook that around there. That's lovely. Right, servo, which is this one. Yellow to S, red to V, brown to ground. That's all connected. Now it says to insert the DC jack from the battery holder. So I will do that as well. Setting up the microbits. Now I'm going to put the microbit back on now. If I can remember which way round it goes. It's going to be that. So transmitter microbit is this one. I wish they were different colours, but they're not. Please check the website about sample hex files, which I'll do in a minute. Powering the receiver microbit, I'm just going to turn it on just to make sure that it powers up. Okay, so I've got a little blue light. The microbit doesn't do anything. I think that's because it's the new one. I haven't flashed it with anything. So that's alright. And for the transmitter microbit, it's saying provide the power externally. Reassuringly, the Hummingworks Valenta website is already up. You can see they're sporting Pi walls, which is brilliant. So they've got manual and assembling guide, tutorial, make code example codes, and there's a bit commander one here. Now the bit commander is a very nice controller for robots. As you can see, it's got 4 buttons, potentiometer for min and max, and a analog joystick. I haven't got one of those, but I'm probably going to buy one because they're very nice. Powered using 3 AA batteries, I think. So the interesting thing with the sample code for the receiver and the transmitter is that what Tomohiro from Hummingworks has done is to explain how it all works, which is brilliant for learning, but they haven't forced you to put it in yourself manually. They just explained how it all works, and that's fantastic, because that way if you just want to play with it you can, and if you want to learn a bit more about it you can. Okay, so for programming the microbits, I've got my 2 microbits, one for the receiver, one for the transmitter. It doesn't really matter which way round it is. And I've got the make code website up here. So what I'm going to do is I'm going to import file, and I'm going to do the receiver first. As you can see, you've got all the code here. Now I don't need to do anything to it, but I'm just showing you that you can edit it. There's also a JavaScript version. Right, now what I'm going to do is I've got the transmitter hex file and I've got the receiver hex file. I've also got the bit commander hex file, which I'm going to leave alone. Got micro USB cable, plug it into the side, plug it into the microbit. So I'm going to take the transmitter file and I'm going to move it across to the microbit. Eject it. So that is the transmitter. I'm going to plug the other microbit in now. As you can see, it's come up again. Now my receiver file was in here. As you can see, you've got receiver hex, which means I can now eject that. So that one is the receiver. I'm going to put the receiver into here and hope it works. I'm going to take the battery pack for the other microbit and plug that in. Then I'm going to lose the laptop. Okay, now we have our Valenta robot. We have our microbit. I've plugged the microbit into the top slot. The buttons on this don't do anything. So what we have is we have our radio controlled remote control. Of course, the good thing about having a microbit as the controller is that I could program the accelerometer so that if I tilted it left, it went left, and if I tilt it forward or back, it would go forward and back. That code isn't on here, but that doesn't mean I can't program it. Whoa! Okay, that works. Whoa! Whoa! And that almost took off over my laptop. Okay, so that's pretty good. I mean, I could do with it being a bit more reactive, so I would probably want to use the accelerometer. That way I could tilt it and it would go at different speeds, but that is all for learning and that is all for adaptation of the controls. So I'm going to look a bit more at the controls and see if I can figure out how it works. On button A pressed, radio send string, go left. So it's all pretty straightforward on the transmitter part. Oh, I see. So the forward and back is the rear 2 motors, and left and right is the servos at the front. So it should, in theory, be possible to be travelling along and shift it to the left or to the right. Now, that's not brilliant for robot control, but that'll do for now. Of course, normally you would have this on the floor. I'm just doing it on the tabletop because I like to live dangerously. So ideally I would play about with it a bit more, maybe get the accelerometer working because that's more of an analog control. So the kit is actually beautifully designed. It uses Tomohiro at Hummingworks parts to create this robot chassis, which I think is very nice. The motors are zippy. The steering mechanism is fun. The microbit electronic stuff is very nice. You know, if you want to put extra servos on or LEDs, you can, because you've got the little expansion pins here. Of course, it's got holes for a lot more expansion on the front. So this could, for instance, have an ultrasonic sensor on the front. That'll probably be something they will bring out. Distance sensors on the side, maybe. turn it into a dune buggy with a bit over the top. I like the fact that they get you to get 2 microbits, because who doesn't love to use radio? And the radio functionalities of the microbit is something I've not come across before, because I've not used the microbit very much. But in order to get them communicating between the two is very attractive. Parts, as I say, are very high quality. The electronics on top is a bit fiddly. I wonder if it would have been better just to have had the microbit plugging directly in rather than have the 90-degree thing. The instructions need a little bit of work, just in order of the sequence that you do things in. I think they could also do with having a little bit of a tutorial on how to program the microbits. I know that's probably something that people have done before, but for those like me who haven't done much microbit programming before, they could just do with just a little bit of help. The example code is good, it's functional. I think they could do with maybe saying, you could of course use the accelerometer, but how you do that is up to you. I'd like to see that sort of challenge being put towards people. As with all of Gareth's products from 4tronix, the electronics are well thought through. The driver board is brilliantly designed. It's got everything broken out. You know, if you wanted to solder extra pins onto the back to access these pins here, you could do. I like the fact that the screw terminals aren't used and that you use headers for them. It takes some of the fiddly stuff out and saves you having to find a screwdriver, frankly. So what do I give it? I would give it a solid, as it is now, 8.5 out of 10. If the instructions were improved, that could easily get up to 9.5 out of 10. What would give you that extra half a point? I would say you need to work on the accessories, so the distance sensors and that kind of thing. If they were already available, that would get 10 out of 10 with the instructions improvements. So I'm going to feed all that back to Gareth, and thank you very much for watching.